Hello, my friends. It's Clover. I just saw this puzzle in the Sudoku testing submissions channel on the Cracking the Cryptic Discord, and I couldn't not give it a try because it has two things that I've really been enjoying lately. Between lines, which is a rule type I've kind of been exploring lately and trying to set puzzles using, and disjoint groups, which is something that's been a trend lately in puzzle setting and has led to some really curious and intriguing and beautiful puzzles. And this is by Just for Kicks. I have done their puzzles in the past. I think I might have actually done their puzzles on stream in the past and have enjoyed them enormously, so I trust that this puzzle is going to be a treat. So here we go. I've never seen this puzzle before. This is a totally blind solve. I'm going to Actually, I'm not going to put a timer up on the screen. I could, it'll be off to the left, but you guys will just be able to see how long this is taking me by looking at the video anyways. So the rules for this puzzle are, first of all, normal Sudoku rules apply. There's also a disjoint group rule, and what that means is that if you have, for instance, a 9 in this cell, then if you look at the top center cell in every other box, none of them can contain a 9. Or if in theory we had a 1 in this cell, if you look at the bottom left cell of every other box, none of them can contain a 1. So all of the bottom left cells have to be different, all of the middle left cells have to be different from each other, all of the top left cells have to be different from each other, and so on. So that's disjoint groups, and you can imagine that leads to some really intriguing logic. Little killer is what we call these arrows. The arrows tell you the sum of the digits along the diagonal they're pointing to, and those digits can repeat as long as they don't repeat within the same box or disobey any other Sudoku rules. Finally, between lines, this is something I've been playing with and setting recently. Between line tells you that the digits along the line, so these digits, for example, are all strictly between these two values. For example, if these values were 2 and 6, then all of these numbers would have to be 3, 4, or 5. And those are allowed to repeat, again, as long as they obey normal Sudoku rules. So the first thing I notice is that there's an interaction between a between line and a little killer. And actually I see two of those. I see one along this 16 and I see one along this 25. I'm not sure which one I want to start with. Let's play with the 16 to start. So the 16 is created with 4 digits, and all 4 of those digits are between these two values. And among other things, that means there's no 1 along this diagonal, and it also means there's no 9 along this diagonal. Now, 16 is a fairly low number, and so what this is making me think is it going to be the case that one of these cells has to contain a 2? Because that would be kind of interesting to me, because that would require that one of the two ends of the between line be a 1. In order to put a 2 on your between line, it has to have a 1 on one of the ends, otherwise you can't put a 2 in between. And I think that that's the case. So suppose that this didn't contain a 2, or obviously a 1, then the minimum along the 16 diagonal would be 3 and 4, 3 and 4. We're already at 14, and if we couldn't add another 2, we'd be at 17. So I think we might have found Just for Kicks' intended break in there. That tells us that one of these has to be a 1, because there has to be a 2 somewhere here. If there's no 2s and obviously there's no 1s, then we can't make a number as small as 16. So one of these guys is 1. The other end could unfortunately be as large as 9. And also I don't know which end is the 1, so could be either of them. The 25. I don't think it's going to be the case that there has to be a 2 included here. 25 is still like a fairly low sum for a little killer clue this long. So if we play with that for a minute, I mean, 3 and 4, 3 and 4, like suppose that those were 3 and 4 pairs. I'm just playing with it to see if I can leave a 2 completely off of this line, because maybe I can make the same argument as I did with the 16. Maybe one of these ends has to be a 1, I'm not sure. So that would give us a sum of 14, that would give us a sum of 17, and then this would have to be at least, one of the ends would have to be at least 5, because it would have to be greater than everything along the between line. And that would give us a total sum of 17 plus 5, which is 22. And then the last value would have to be no greater than 3. Interesting. Yeah, so the other end would have to be at least 5. Yeah, so that we could definitely reach 25 without using any 2's, which would mean that in theory a 2 could be on one end of here. So that's not the direction we want to go in yet. How about these? These ends both see the 8. Unfortunately, they don't see the 9. This makes me think, so whenever you see a between line, first of all, if both ends see a certain number, that's pretty powerful because that tells you that number isn't on the between line. I mean, it isn't one of the bounds for the between line. What else I see is that unlike some of the other between lines in this puzzle, this one has 3 numbers in a row, which means that there must be at least 3 distinct values between here and here. So for example, this can't be 1 and 4 on the two ends, because then we would have to go like 2, 3, and then the question mark. What goes there? That's not quite enough to let me even pencil in any numbers yet. So I think there's somewhere else I have to go. Now, I just realized that I haven't been thinking about the disjoint group rules yet, and that's actually going to be helpful here. So it just struck me that I concluded one of these had to be a 1. These are actually both bottom left cells, which is going to be super powerful, I just realized. So that means that none of the other bottom left cells, including these and these, can be 1s, because either this one or this one is definitely a 1. And that tells us that the minimum value along this 25 is, in fact, at least a 2. It's like the opposite of what we were trying to prove earlier. So one of these has got to be at least a 2. Now my question is, does it have to be a 2? I mean, is it possible that the minimum value here could be a 3? Like, could we bound the between line with a 3 as its low end? I don't know. I'm going to test that. So 4 and 5 would be the minimum in each of those. That would be 4 plus 5 plus 4 plus 5 is 18. Plus another 4 at a minimum would be 22. Plus, if we had a bounding 3, that would take us to 25, and plus we'd also need the high end. So that tells us that one of these two ends, so if it's a 3 on one of these two ends, we end up with too much pressure. We end up with a number that's definitely bigger than 25. So one of these has to be a 2. That's the only way to make this work out. And once again, these are both in the bottom left corner of their box, which means neither of these can be a 1 or a 2, because we've already used the bottom left corner 1s, we've already used the bottom left corner 2. That does mean that at a minimum one of these is 3, and so both of these have to be 4 or greater. I suppose I can pencil mark that in now. They can't be 9, because then how could they be between 3 and something else? 9 isn't a between digit in a Sudoku. It only goes up to 9. So that's obviously something we were supposed to notice. I'm not sure if I completely appreciate yet what that's used for, but we'll keep that in our pocket. What else do we see? So this cell, this is one of just 2 given digits. It's a right center cell, which means that this can't be an 8 because it can't repeat. None of the top center cells can be 9s, but that doesn't restrict anything that we have yet. So maybe we should be looking at some of the other little killer clues that haven't kind of clearly interacted with the between lines yet. That's a possibility. Or maybe we could be looking here. This is somewhat restricted. I don't know if it's restricted enough to do much. Obviously, this cell can't be a 1 or a 2, can't be an 8 or a 9 because there's 8 in the box. So it's at most 7 and at least 3. And maybe I should be thinking about maxima along here. This can't be a 9 for 2 reasons. It sees a 9 and it's on a between line, so that's an 8 at most. That's a 9 at most. Yeah, that's not really restricted on the maximal end. Now what? I mean, it's possible there's something... Maybe I didn't do enough with this. So I know that there has to be a 2 here. I mean, is it possible that this is restricted enough at this point, knowing that there's a 2 minimum, that the values left over have to be pretty low? So, like, knowing that there's definitely a 2 there, the minimum there is going to be a 3-4 pair. The minimum there is going to be a 3-4 pair. That accounts for 14. Plus the 2 is 16, which means that the sum of our remaining digits is at most 25 minus 16, which is 9. And that means that if we had a 3 as our remaining digit that's kind of alone here, the most we could get for our maximum would be 6. And if we had a 4, the most we could get for our maximum would be 5. And we can't go bigger than 4, because if we put a 5 there, then to sum to 9, we'd have to have a 4 on the maximum end of our bulb, and that's not possible because we have a digit bigger than 4 along the line. So that is pretty restricted. I believe that implies that we have a 2 here. The maximum has to be at most 6, because even if we make everything here absolutely minimal, we're only left with 6 to make up the 25 sum. So one end here is 2, and then the other end is either 5 or 6. Is it possible to rule out the 5 case entirely? Because if the ends are 2 and 5, that's really restricting as far as what we can even put in these squares. I mean, every number along the between line has to be between 2 and 5. That's just 3 and 4 if they see each other. So that would be 3, 4, 3, 4. That would be a total of 14. Plus 2 plus 5 would be 14 plus 7. Plus that last digit would have to be a 4. No, that's not a problem. That's actually okay. Oh, I just realized something though. So I'm not sure that this is going to do anything for us just yet, but it is interesting. So don't forget between lines here. These two cells, or no, don't forget disjoint groups here. So these two cells, this cell is part of the same group as this cell, and then this cell is part of the same group as this cell. That doesn't really do much for us now because we could still have an arrangement like that, and that would be valid under the disjoint groups rules. But again, it's like something to keep an eye on. Can we? God, I just have this feeling that we can go further with that I just can't quite shake. I mean, maybe we can come up with some similar reasoning to constrain the maximum end of the 16 between line. So we know that one end is 1, so our absolute minimum along the line is 2 and 3, 2 and 3, meaning that, so that sums to 10, meaning that the maximum we could put here is 6. So this has got to be 2, 3, 4, 5, or 6. The minimum we could put here is 2, meaning that the maximum in any of these cells on the outside is 7, which is not that interesting. This is moderately interesting, but not as restricting as I hoped it would be. Is it the case that we have to have 3s in both of these groups here? Because that would place some 3s in our disjoint groups, which would be useful. I wonder if that's the case. So is it possible to have like a 4 and 5 pair in 2 of these cells along this between line? I mean, that, to minimize everything else, that would give us 2 as a minimum, plus 4 plus 5 gives us 11, plus a minimum here of 3 gives us 14, plus a minimum here of 3 and 4 gives us 14 plus 7 is 21. And then we'd only be left with 4 to play with for the maximum end of the bulb, which is not cool. So that, we just proved that we can't have one of these pairs fail to contain a 3, because if it contains the absolute minimum it can without a 3, which is 4 plus 5, even if you minimized everything else, you still couldn't fit everything into a sum of 25. And that means that both of these pairs have to contain a 3. Because if we make either of them 4, 5, everything breaks. And that does impact the disjoint groups. It means, for example, that none of these top center cells can be a 3, other than maybe this one or this one. It also means that none of these right center cells can be a 3, other than maybe this one or this one. So what do we notice from that? Oh, and it also tells us that nothing in these squares can be a 3, other than potentially these two cells. So no threes there. Does that intersect with any of the between lines? It certainly implies that if there's a 3 along this between line, it's got to be there. What was the maximum here again? So 3 plus 4 plus 3 plus 4 is 14, plus 2 is 16. That left us with 9 left over, meaning that the maximum here, I believe, was 4. So this has to be either 3 or 4. Okay, that's cool. Sorry if you guys heard that. That was my antivirus making a noise. I'm actually not sure if I'm sharing my computer sound with you. I'm very new at this. So either this is a 3 and this is a 3, or this is a 3 and this is a 3. And then 3s are restricted all over the place otherwise. And those contain no 3s. And these contain no 3s. Interesting. Is the 37 restricted? So, I mean, this part of it, all of these orange cells can't contain a 3 because of the deduction we just made. They could, however, contain 1s and 2s, because the only restriction on 1s and 2s is kind of in the bottom left corners. And none of these can be 3. Hmm. Hmm. Like, what I'm thinking about now is whether maybe I can convince myself that one of these ends has to be a 3. I don't know whether that's going to be the case. So I do know that there's now another restriction on this 16 little killer. I think this may be the right direction to go in. Because previously when I was playing with minima and maxima, if you remember, I had 2 3 pairs filled out here to establish minima along the 16 between line. But those can no longer be 2 3 pairs at a minimum because the 3 is used. So now the minimum is actually a 2 4 pair. If we had 2 2 4 pairs, that would be a total sum of 12, which would leave us only 4 left over. So that can no longer be 5 or 6. That actually has to be 2, 3, or 4. Does that actually mean that these guys have to contain 2s? So suppose that these didn't contain 2s. Suppose one of these pairs of pink cells here failed to contain a 2. Well, it can't contain a 1 because it's on a between line. It can't contain a 3 because there are 3s in the cells already, both along the 25 little killer. So if there's no 2, then the minimum here would be a 4-5 pair, and that seems to me like it probably shouldn't work. A 4-5 pair would give us 9, and then we would have at least 2 there, which would leave us with at most 5 left in these cells. So 9 plus 2 would be 11, leaving us 5 left over to somehow fit into these 2 cells. Well, we can't use a 1, so that rules out the possibility of doing 1 4 to make 5. We can't use a 3, so that leaves out the possibility of using 2 3. We can't make anything smaller than 5 because, like, to make 3 we'd have to do 1 2, to make 4 we'd have to do 1 and 3. Like, those are all impossible. They require a 1. So that tells us that just like up here, we've just figured out that each of these two pairs has to have a 2 in it, because otherwise the whole thing ends up being too big to fulfill the 16 little killer. So there's a 2 in that pair and there's a 2 in that pair. And that lets us make a really similar deduction to the one that we just made. We've used the 2 in this disjoint group. We've used the 2 now in this disjoint group. So everything else that's along any of these can no longer be a 2 because the 2's in those two groups have to be in that set of 4 cells somewhere. So none of these cells that I'm highlighting can contain a 2. On top of that, none of these cells can contain a 2, but that doesn't seem as immediately important. And because we placed our 2's in the bottom left, so we can also highlight the bottom left cells that we know don't contain a 2. And that's like very, very restricted. I mean, these are the only places where our 2's can go. So I guess we know the 11 clue doesn't include a 2. Not really useful. Okay, so we've limited where we can put 2's. Oh, and also that clearly can't be a 2 because it has to be a 3 or 4. I wonder where to go from here. So we've found some 2's, we found some 3's. Beyond that, if that's 2 and 4 and 2 and 4, that would have to be yet another 2. Is there maybe an interaction between these? For instance, if this is 3, neither of those could be 3, but it could just be the case that those two are 3. Maybe there's a problem if these are 2-4 pairs. Maybe these can't be minimal. That would take away a degree of freedom, which would be nice. Is there an issue with those being 2-4 pairs? I don't think so. I guess we do know now that this isn't a 2, but this could be a 2. And I mean, they could be 1s as well. So what else? So the minimum here has to be at least 3. Let's maybe look at this one for a minute. So the minimum here has to be at least 3 because it can't have a minimum of 1 because that's already taken. It can't have a minimum of 2 because that's already taken in the bottom left corners. So the minimum is at least 3. There are 2 distinct cells in between the minimum and the maximum. That means the maximum has to be at least 6. So one end is 3, the other end is 6, 7, 8, or 9. If one end is 4, then the other end is 7, 8, or 9. If one end is 5, then the other end is 8 or 9. And if one end is 6, then the other end is 9. So that is not very restricted. There's probably something I'm not seeing there. So where to? I mean, I've got a lot of places now where there can't be a 2 or a 3 in certain places in the disjoint group. So for instance, we can't have a 2 or a 3 in the middle here, or in the middle here, or there, or there. Those can't have 2's or 3's. And that means that the 2's and 3's along kind of the main diagonals of boxes have to go somewhere else. This 11 can't contain a 2. Don't know what that means. Does this have to have a 3? Yeah. I don't think we're going to get anything out of minima and maxima using this and the 37 line, but it's worth a try because I'm not totally sure where to go next. So let's say that this is at its minimum. So one end is 3, the other end would be 6. And then these two cells would be 4 and 5. 3 plus 4 plus 5 plus 6 is 18. That gives us 19 left over and 4 cells. 4 cells which can't be 3, but they could be just about anything else. I mean, maybe there is an interaction going on here. Like, if you look at one thing that strikes me is the way that these little killer clues are placed. This 37 little killer clue, for example, crosses through multiple cells from the same disjoint groups. And the same is true of, for instance, this 25 clue. It only crosses through like bottom left cells, top center cells, and right center cells. So these have to be different. These have to be different, but that doesn't keep them from being 3-4 pairs. 25 plus 37 is 62. And here we have 1, 2, 3, 4, 5 top center cells. 1, 2, 3, 4, 5 right center cells. And 1, 2, 3, 4, 5 bottom left cells. That's got to be significant. So the sum of those is 62. And that's actually just 3 sets of 5 distinct cells. Some of them could contain a 1. So the green and blue cells could contain a 1. So their minimum, I imagine, is 1, 2, 3, 4, and 5. So like the minimum for the sum of the green cells there is 15. The minimum for the sum of the blue cells there is 15. That would give us 30. The minimum for the sum of the red cells, though, because those can't contain a 1, would be 2 plus 5. So that's a minimum. And I'm actually going to grab a notepad so I can just take some notes on my end. So 2 plus 5, which is a minimum, plus 3, possibly, along here, plus a minimum of 3. Oh, though that would mean if this is a 3, that couldn't be a 3. So 2, 3, 5, could be 4 and 7. So 2, 3, 4, 5, and 7. I don't think we can do 2, 3, 4, 5, 6. 2, 3, 6. Yeah, because these need to be fairly different from each other. That could be 3 and 6. We could go 2, 4, 5, 3, and 6. So it could be 2, 3, 4, 5, 6 in the reds, which would be a total of 20. So then we would be at 20 plus 15 plus 15, which is only 50. So a minimum isn't quite going to cut it there for us. But I really feel like we're onto something. And is it the case that there can't be any 1s in any of them? Because then a sum of 62 would be really powerful all of a sudden. Because if there couldn't be 1s in the green or blue, that would give us minima for green, blue, and red of 20 plus 20 plus 20, which would be 60, which is very close to what we actually have in the little killer clues. So is there some reason there can't be 1s? Like, not that I'm aware of, unfortunately. Oh, this one? This little killer clue also goes through the same exact sets of numbers, so maybe we could also add that in to see if we could restrict even further. So there's green, green again, and also red and blue. So now if we're looking at all 3 of those, we have a total of 7 green cells, 7 blue cells, and 6 red cells, which cannot contain a 1. So the red cells, again, have a minimum of 2 through 6, which is 20. The green cells have a minimum of 1 through 7, which is 28. The blue cells have a minimum of 1 through 7, which is 28. So that gives us overall a minimum of 76 across all of those. And the actual sum is 25, 25, and 37, which is 87. So that's not very close to being bounded. Oh, that's so frustrating. I really thought I was onto something super clever with that. Well, maybe we can still use the same thinking, we just need to use it somewhere else. I mean, maybe it's this 16 and 11, possibly? So that's a total of 3 of these cells, 3 of these cells, and then this random top right cell, which is 2, 3, or 4. So then that's got a minimum of, none of them can contain a 1. 1 is a bit restricted, actually, in these sets of disjoint groups. Not as restricted as I would like, though. Because neither of these can be a 1 because of the 11 sum. None of these can be a 1 because they're along a between line. And where do the 1s have to live? Okay, we're changing approaches. We're going to look for 1s. And we're going to start by saying anything that's along a between line can't be a 1. Also, anything that's in a bottom left corner that's not one of these cells can't be a 1. So those are all out. Those can't be 1s. These can't be 1s because they're along between lines. They have to be between 2 other numbers. Those can't be 1s because they are not 1s. These can't be 1s because you can't make an 11 out of just 2 numbers with one of them being 1. The other one would have to be 10. And so, I mean, is it possible, like, can any of these be 1s? Yeah, those could easily be 1s. Because that could be, 7, 8, 9, and then it wouldn't even be big enough, let alone being constrained. And I do see these 2 places where, like, all 4 of these cells are constrained. There are a lot of places where kind of the top right is constrained, so the only places where we could put our 2 1s in the top right is there, 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 and there. Okay. There's got to be something there. Like, there really has to be. Not yet. Maybe we go back to looking at bottom left corners. So this is the next obvious place to go with that. The minimum there can't be a 1 or a 2. It's got to be a 3, 4, 5, or maybe a 6. So if the minimum here is a 6, then this would have to go 6, 7, 8, 9, which is already 30. And I don't think we can make just 7 here and here with what we're already missing. We can, though. It could be, for instance, 1 and 2 and 1 and, well, not 1 and 2, 1 and 3. Can we make 7 with this without being able to use a 3 in any of those top rights? I mean, could it be like 1 and 4? I'm pretty sure, so what I'm noticing is, like, if we maximize this, which would mean it had a minimum of 6. So if the minimum there was 6, then these two would have to be 7 and 8 in some order. Obviously, it can't be like that, but I'm just putting this in to illustrate. And then the maximum would have to be 9. And then 6 plus 7 plus 8 plus 9 is already 30, which leaves us with only 7 left in these 4 cells. And if we only have 7 left there, well, we definitely have to use 1s in both of them, because if we don't use a 1 in one of them, like the minimum would be 2 and 3, which doesn't even work, but just work with me. The minimum would be 2 and 3, and then we'd have to put 2 more 1s somehow over here. We can't put 2 1s in the same box. So like they both would definitely have to contain a 1. And then we'd also need 5 more, which we'd have to make by doing a 2 and a 3. Well, we can't use a 3, because we've already placed our 3s in those disjoint groups. And all that tells us is that the minimum here cannot be 6, because that gives us too big of a sum along this line. So the minimum has to be 3, 4, or 5. One of these has got to be 3, 4, or 5. One thing we haven't thought about yet is the number 9. 9 also can't ever appear along a between line, just like 1. And the one thing that makes 9 maybe more promising than 1 in this puzzle is that we've been given a 9. Maybe that's where we're supposed to be looking. I'm going to highlight things that can't be 9. So we've already have a 9 in a top center disjoint group, so that's taken care of. None of these can be 9s. So none of these digits can be 9. Those could, in theory, be 9 as long as the minimum was greater than 6, or was less than 6. So is there anything else? Neither of these can be 9, because if one of these was 9, the other one would have to be 2, and we've already used up our 2s for those two disjoint groups represented by these squares. And what does that mean? Are there any cells where we can not put a 9? Are there any cells where we have to put a 9? This bottom center is blocked off in some of them. This bottom left is blocked off in some, but not all of them. Bottom right, not really restricted. Where could we have a 9? It would be difficult, but not impossible, to put a 9 on this 25. Does the 37 have to have a 9? No, not at all. Not even remotely. The 12 could have a 9 if this was 9, 1, and 2. No. So those both have to have a 2. So that's a minimum of 6 accounted for. I mean, I think our maximum here is going to be 2 plus 7 plus 2. Nope. 2 plus 6 is 8 plus 2 plus 2 plus 4. So the largest number that could be in any of these squares is 6. And obviously can't be a 3, because we've already accounted for that 3. Here, the minimum, if we have 2 and 5, is obviously these are all going to have to be 3 and 4 in that case. Or if it's 2 and 6, they could in theory be 3 and 5. So if it's 2 and 6 on the ends here, that would account for 8, which would give us 17 left to play with. That's a minimum of 3, which would give us 14 left to play with. Oh, okay, so here's what's going on here. I don't know if this is going to get us anywhere, but if you look at the 25 little killer, under what conditions can we get anything other than 3, 4 pairs here? So the only way to put any 5s along this line is if the maximum end of the between line is greater than 5, which is to say it's 6. But if it's 6, So if this is a 2, 6, we've already used up 8 of our 25 total, which leaves us with 17. This is a minimum of 3 for other reasons, which leaves us with a maximum of 14. But how do we make 14? We can only do it by going 3, 4, 3, 4, so we don't get to use those 5s after all. So we can't use the 5s if our maximum is only 5, but if our maximum is only 6, our numbers are too big to get to use 5s anyways, and that means we can never use 5s on here. And so that means those are 3, 4 pairs. And that means that we can't actually use any 4s along the 16, which means we have to look at our values again along the 16. Our minimum along the 16 now is 2 plus 5, 2 plus 5, which is 7 plus 7, which is 14. And that gives us this at our minimum value. This was a minimum of 2. So that has to be exactly the situation. These have to be 2, 2, 5 pairs. Oh, that's fantastic. So now we know we've accounted for our 4s in these disjoint groups, so neither of these can be 4. We know we've accounted for 2s and 5s kind of on the bottom left. We know that one of these has to be 1, one of them has to be 6 or greater. Oh, and by the way, is this a 2, 5 or is it a 2, 6? It's going to depend on whether this is a 3 or a 4, if I'm not mistaken. Oh, that's got to be useful. That's really lovely. That's just absolutely lovely. I know I'm kind of stealing a Simonism there, but it really is. So, we've established, I guess, that this has to be a minimum of 5 and 6. These can't contain any 3s or 4s. I think maybe we have to go back to this and say, well, now that we know we can't use any 3s or 4s, what can we use? Oh, before we do that, because these now can't have 3s or 4s, the minimum of them is 5 and 6, which means that our large end of this has to be at least 7. So one of these digits has to be 7, 8, or 9. And then the other one has to be 3, 4, or 5. Not useful. I mean, if that is 5 and 6, that would be a sum of 11. Then the minimum there would be 3 and 7, which would give us another 10, which would be 21. And that would mean these would have to sum to 16. How viable is that? I mean, they could contain 2s. There's no reason they can't have 2s in them. They just can't have 3s or 4s. They could have 1s or 2s. Okay. Disjoint groups are tough. They really are a very, very tough puzzle type. One of these ends has to be 1, and then the other end has to be 6, 7, 8, or 9. And then these are also all 1, 6, 7, 8, or 9. Ah, so now the 11 sum, we already knew it couldn't have a 2 in it, but now we also know it can't have a 5 in it. So it's got to be either 3 and 8 or 4 and 7. So close to a breakthrough here. So close. If I keep saying that, then that breakthrough will come. Let's revisit where we can't place a 2. Maybe something will pop out at us. So we can't place any 2s anywhere in this box other than along the 16 line. Can't place any 2s there. We can't place any 2s in top right corners. Can't place any 2s there, there, or there, or there, or there. That's interesting. The 2 has to be along there. We can't place any 2s there, or there, or there, or there. These ends can't be 2. There can't be any other 2s in bottom left corners. These obviously can't be 2s. These can't be 2s. These can't be 2s. And those can't be 2s. So we do have these 2 cells, or these 2 boxes, which contain 2 of our 2s, and they're restricted to the same set of 3 disjoint groups. That does imply that, like, if we had a between line going like this, there could only be 1 2 along it. The problem is that we don't have a between line going like that. This between line might be restricting something at this point. And if one of these ends, the ends could be as low as 1. What am I not seeing here? The 11 seems like it's really just almost restricted. Maybe we want to do like 37 plus 25 again? Take another look at that. So green can't contain 3 or 4. So the minimum of green is going to be 1, 2, 5, 6, 7. Blue can't contain 2 or 4, so the minimum of blue is also 1, 2, 5, 6, 7. So those are both 21. That's a total of 42 accounted for. Pink can't be 1 or 2, so it's a minimum of 3, 4, and 5. That's 12. So that's 42 plus 12 is 54. And the total here is 62, unfortunately. That's not it yet. Oh gosh. Oh yeah, but there is more of a restriction here. These definitely can't be 3, 4, and 5 because one of these has to be 7, 8, or 9. So the minimum is actually 3 and not 4, because if one of these was 3, this would be 4, not the other pink one. So 3, 5, 7 would be the minimum here, which would be 15. So now we're a little closer. We're at 42 plus 15, which is 57. And we need to get to 62. And the minimum there is 3, 5, and 7. There's definitely some kind of an interaction. Just don't know what it is. So if one of these is 3, then the 4 is going to be used here. And if one of these is 4, then the 3 is going to be used here. Meaning that we can't have like 3, 4, and something else. And could these actually even be 1, 2, 5, 6, 7? Or do we need to actually restrict that even further? Mm-mm. Can't be 3 or 4. Can't be 3 or 4. I mean, what's the maximum? The maximum's not going to do it. It's going to be way higher than 62. So the minimum here is now 3, 5, 6, and 7, which is 21. So the maximum here, 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 and here is 16. We don't necessarily have to have any 1s. I mean, we do have to have 1s or 2s. Because if one of the sides has no 1s or 2s, then that would have to be 5 and 6, which is 11. And one of the sides could have no 1s or 2s. This is really, really, really confusing. Really tough. And I'm really at a bit of a loss. I'm not sure where to go with this. Because I'm not doing this live, I can't very well get hints. I wish I could. So let's maybe bifurcate a tiny bit. If one of these was 3, like if the minimum here was 3, can we show that it's not? I mean, can we show that the minimum here is not 3? If one of them was 3, then that would definitely have to be 4, which would force this to be a 2 and a 5 to keep the sum low enough. That would have to be 7, 7, 7, and 4. That couldn't be a 3, 4, or 5. I don't think that causes any issues, unfortunately. I wish it did. Okay. If one of those is 6, then that would have to be a 3. The The 12 is completely unrestricted as far as I can tell. There are no disjoint groups restrictions on that, and it seems like there are no restrictions just from the fact that the little killer's a 12. Along row 4, 1 and 9 are a little bit restricted. And 1 and 9 have to be in these 3 cells because they can't be along a between line on row 4. Two also either has to be in one of those cells, or it has to be along here, which would imply that this between line has to end with a 1. I mean, 2 can't be here or here because there's already a 2 used there. So 2 is either here or it's along the between line. If 2, oh, 1 and 9 could, never mind, that whole line of reasoning is flawed because 1 or 9 could be on the end of this between line. So there's nothing stopping that. Do some crazy pencil marking, I guess. This isn't going to help. I don't know why I'm doing it. I really don't know. I really don't know. I'm at a complete loss. I know this has been like a really boring 15 last minutes of this video. 37, 25. Could these even be like 7 and 8? Could this even be 7, 8, 9? We know it can't be 6, 7, 8, 9. Could it be 7, 8, 9 and then something smaller? I mean, if it's 7, 8, 9, that would sum to 24, which would give us 13 left over to play with in these cells. This would have to be at least 3, which would give us 10 left over here. And that's definitely possible. Hmm. Am I just not adding the right things together? It's all of, so these lines go through kind of bottoms. We've already taken care of that pretty much. These lines go through tops. We tried really hard to make this work, adding these two together, but that got us nowhere. And even adding them together with this is not really going to help a lot because that's effectively what we were already doing. 2, 5, 3. And maybe we did discover a more significant restriction on these cells. Okay, so here we have 7 pink. I know I've already done this. I just want to look at it again. 7 green, 7 pink, and 6 orange. So the 7 green and 7 pink are at a minimum of 28 each, so a minimum of 56. The 7 orange, or 6 orange, are a minimum of 2, 3, 4, 5, 6, 7, which is 27. So orange, 27. Pink, 28. Green, 28. That's a total of 56 plus 27. Did I maybe do the math wrong last time? Which is 83. And now 25 plus 25 plus 37 is 87. So that's like kind of close, I guess. 83 versus 87. So the minimum that we have there is 83, and the actual minimum is 87. And 27 plus 28 plus 28 is 83. And then 25 plus 25 plus 37 is 87. And that's 4 degrees of freedom, which is not enough in a little killer, especially given the number of cells that we're considering here. And then just doing these didn't get us anywhere. Pink. So that's 5 pinks and 5 greens. Minimums of 1, 2, 5, 6, 7. So minimums of 21 in pinks and greens. That's 42. And in the orange, the minimum is 3, 5, 7. Is really bugging me. I'm really absolutely at a loss. Which is unfortunate because I was enjoying the beginning of this puzzle and now I'm just completely stuck. So 3, 5, 7 is 15. 15 plus 21 plus 21 is 15 plus 42 is 57. And here, unfortunately, we have 62, so we still have 2 degrees of freedom. Oh, sorry, lots of degrees of freedom, not just 2. I guess we know that, I mean, we do know both pink and green have to contain 2. Because there's nowhere else that you could have 2 in those disjoint groups. It obviously can't be up here, 2 can't be there, here, because there's a 2 in the box. So pink and green definitely both have to contain 2. Some of these probably can't contain both of them, so like the 25, could the 25 contain both 2s? I guess it could, I don't see why not. It could contain like a 2 here and a 2 there. They don't both have to contain 1. And you can't have a 1 there, or there. Or there or there. They could totally both contain 1 though. Because 1, 2, 5, 6, 7 worked just fine. So I don't know, like maybe one of these has to be 1, maybe it doesn't. I just don't know. What haven't we used? We haven't used this between line at all. Literally haven't touched it. We haven't used this, the 37 clue. We haven't used this 25 clue. We haven't really used the 12 clue, though we thought about it a little bit. Okay, maybe we can use the 25 clue? I did just notice something. If you look at the bottom left corners, I guess the places where we could have an 8 or a 9 are fairly restricted. Not like very, though, unfortunately. Like this can't be an 8 or a 9. These can't be 8s or 9s. This could be an 8 or, like, so one of these could be an 8 or a 9. One of these could be an 8 or a 9. Or it could just be like one of them, either way. And then this one could be either an 8 or a 9, possibly. There's no problem with that. Like, because it's a between line puzzle, you know that between lines can have one high end and one low end. So if their ends are both in the same disjoint group, you know that that accounts for one high number and one low number in that disjoint group for various definitions of high and low. Hard to say exactly what that is. So like this contains one digit from the set 6, 7, 8, 9. And like suppose this was a minimum, like suppose this was 1 and 6. Then this would have to be 2 and 5. So we've accounted for 1, 2, 5, and 6. So we still need 3, 4, 7, 8, and 9 to go here, 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 and here. Well, 8 and 9 can't go there or there. They can't go in both of those squares, meaning one of them would have to go here. But that's only if we knew that this was like a 1 and a 6. And if we consider numbers like from the set 6, 7, 8, 9, we can only have one of the 6, 7, 8, 9 numbers here. We could have one of them here. Or maybe if we just consider 7, 8, 9. We could have one of them here, we could have one of them here. Ugh, we could just barely have a 6 there. It's really bugging me. Like, can we rule out a 6 there somehow? Oh, geez. Like, really don't want that to be able to be a 6. And it can be a 6, right? If it's a 6, that's 25 minus 2 minus 6, which gives us 17, which is 3, 4, 3, 4, and 3. That's fine. It's definitely not true that either of these has to be 3, I don't think. I think either of them could be 4 with no 3, or 5 with no 3, and that would be okay. So, like, one of these is a high number, okay, these contain one number from the set 3, 4, 5. These contain at most one number from the set 3, 4, 5. This could be a number from the set 3, 4, 5. So 3, 4, 5, 3, 4, 5. And this contains at most one 8 or 9. That could contain an 8 or 9. Can I show that those both have to contain an 8 or a 9? Not as far as I can tell. Is there like a rule I'm missing or something? I don't think so. Just got normal Sudoku, disjoint groups, little killer, and between line. As far as I'm aware. Maybe this isn't. Maybe we can go even further with like reducing the maximum on this. Like maybe we could show that this couldn't be like 5, 6, 7, and 8. And is that allowed? Maybe we could show that it can't have a 9 in it or something. Like that was just so fragile, like proving that it couldn't have a 6, that I feel like that probably wasn't even where we were supposed to go. And maybe, like, is that not allowed? So this would be a sum of 26 here, which would leave us with 11 more here that we needed to make. Which we could do pretty easily, I think. It could be like 1, 1, 2, and 7 or something. So that would be fine. Keep coming back to this, like, where could the 8 or 9 be? Like, it's possible that one of these is an 8 or 9, or one of them could just be a 7. Well, maybe that's not possible. Maybe like 5, 6, 7 is not allowed, and then 3 or 4. Like, is that maybe not allowed? Like, maybe, like, what would happen if we did that? That corner would have to be a 5 or a 6. These could not be 7s. So our 5 and 6 would be, so this would be a 2, 5, 6 triple. So those couldn't be 6s. One of those would be a 1, and then the other one would be an 8 or a 9, so that would be an 8 or a 9. And that's fine. It's totally fine. So minimizing this is fine, maximizing it's fine. 25. This can't, that can't be a 1. I don't know. One of these is a 5, and the other two couldn't be 5. Those couldn't be 5. Making this a 3. Meaning these couldn't be 6s. Those couldn't be 5 or 6 or 3. And what's the high end of this between line? It is restricted a little bit by there being like a 3, 4 there. So like this can't be 3 or 4. It could be 2 though, is the problem. It could be 2, 5, 6, 7, or 8. Whoops, I meant here. It's gonna be a 2 here, there, 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 or there, there. So those we've got to account for 2 2s. I mean, the 1s and the 2s that are left over, and these kind of 2 top, like the 2s are a little easier because of this box here. Like, none of these can be 2s in those 2 positions, the between line. And those can't be 2s, obviously, which means that we have to have 2 2s across these 8 squares. Is there a similar game we can play with 1s? Not that I really see. And the 1s could easily be like here or here. So these have got 2 2s. So 2 2s accounted for, which would take our sum of 36 plus 25, which is 62, down to 62 minus 4, which is 58. And that just doesn't work. Like this minimum maximum here, like I just keep coming back to that and it just keeps not working. So bottom left, one of these is low, one of them's high. One of them's low, one of them's high. So one of them's 2 and then one of them's 5 or 6. Now the problem is I don't know if I'm counting 5 as low or high here. One of these is 1 and then the other one's high. This could be either low or high. So one of these guys is 6, 7, 8, 9. One of these guys is 6, 7, 8, 9. We need 2 more 6, 7, 8, or 9, and we have effectively 3 places to put them. We could put it here, we could put a 6 on one end of those, or we could put it here. So why can that not be a 6? Why can those ends not be a 6? I mean, maybe we just bifurcate on that. Maybe we just say, all right, like let's say this is just 2 and 6. So none of these ends are 6. And that just means 25 is 8 plus 7 plus 7, 22 plus 3. It's 25. And so one of these is low, and then the other is 7, 8, or 9. One of these is 7, 8, or 9. And that means like one, but not both of these is 7, 8, or 9. This is just making me feel absolutely dense. Been at this for an hour and 21 minutes, and I have one digit. Those are those two runs where we can have twos again. One of these guys has to be a 2, but we don't know which. And then none of these can be 2s. Can the 25 have two 2s in it? Like, would it be possible for the 25 to look like that, or is that impossible? That would leave us with 21 here. This is a maximum of 8. This is a maximum of 9. It's a maximum of 17, so that would be 4, 5, 6, or 7. 2 and 2. 8 and 9, that would be totally okay. So it could definitely have both 2s in the 25. Oh, I guess, so here are some cells where we need a 2. And then we also need a 2 there. Oh, those are equivalent. So we need a 2 in one of those 3 cells for sure to satisfy that disjoint group. And we need a 2 in one of these cells to satisfy that disjoint group. And then finally, we need a 2 somewhere in here, we need a 2 somewhere in here, and then we need like one more 2. Like in here, or in there, or in there, or in here. I mean, if this guy's a 2, then that has to be a 2, so this cannot be a 2. Neither can these. So this would lead to this situation. And that's okay. That's allowed. So this would have to be a 2. Oh. Well, this is kind of obnoxious. I mean, we just did find a contradiction, but I don't know if I understand where it came from. So, I mean, one of these has to be a 2. It can't be, I just realized it can't be here. Because if the 2 is here, wait, no, it could be. Never mind. But that does put some restrictions on things. Like if the 2's here, then that means our 2's along this line have got to be there and there. So that's restricted. If there's a 2 here, that means our 2's along this line have to be here, and because we can't repeat in the disjoint group, there. And so this, wherever this 2 goes, does kind of control where the 2's go along this line. Interestingly, I don't think it can ever be both of the outside ones, can it? Oh yeah, it totally can. Now, where the 2 goes along here also restricts things. So like if this is a 2, then we know where our 2's are. They're there and there. Ah, interesting. Okay, here's what we've been missing for an hour and a half. So if this is a 2, so we know one of the ends of this between line has to be a 2. So if this is a 2, 2 can't be there, so it has to be there. That means 2 can't be here because of the disjoint group, so it has to be there. On the other hand, if this is our 2, 2 can't be here, so it has to be here. And 2 can't be here because of the disjoint group, so it has to be there. Whew, so we actually know that regardless of which of these ends is a 2, our other 2's are there and there, which makes these 5's, which keeps either of these from being a 5. Which means that the large end has to be at least 8 on this between line. So it's 6, 7, 6, 8, or 7, 8 on that between line. It also means that neither of these can be 5, so we're in 2, 6 land. Which means that has to be a 3 in order to fulfill the 25 between line. The 25 little killer. Because that's a 3, this can't be a 3. And neither of these can be 3's. Now we're cooking. We're getting somewhere, sort of. Arguably. It's a start. So then where does the 3... Oh, there's the 3 in the bottom left corner. So we've got 1, 2, and 3 accounted for. So let's clear out our highlighting, now that we kind of understand what's happening there. Okay, so that's 2, 6. Which means one of these is 6, which means that neither of these can be 6. Similarly, that can't be a 6. So there's got to be a 7, 8, or 9 on one end there. There's an 8 or 9 on one end there. So that's 2 of those large numbers accounted for. The last one could either be here, and it would be a 7, or it could be there, and it could be a 7, 8, or 9. Okay, these can't be 3, so now their minimum is 4, 6, 7, 8. So that's a minimum of 25, which leaves us 12 to play with here, at most. Does that mean we have to have 1's and 2's up there? Well, none of these can be 2's, because now they're all seen by 2's. Like, literally none of these can be 2's anymore. So we gotta make 12 somehow. We can't use 2's, we can't use 3's, and we can't use 4's. So that means the only way we can make 12 here is with one of 5 pairs. And then this has to be at its minimum. This has to be 4, 6, 7, 8. And that together, I believe, I hope, sums up to 37. So 4 plus 6 plus 7 plus 8 is 25. And then we can't use, in any of the orange squares, 2 because they're all seen by 2's. We can't use 3 and 4 because we've already used up our 3's and 4's in these 2 positions for the disjoint groups. So that's a minimum of 1, 5, 1, and 5, which is 6 plus 6, which is 12. 12 plus 25 is 37, so everything has to be at its minimum. Perfect. Oh, that is disgustingly clever. Disgusting. Can't even believe it. I think we've probably used almost everything in these positions now. We've used 1, 3, 4, 5, 6, 7. So we need 2, 8, and 9 up here. So in all of these little corner spots, we need to account, the only things we have left to account for are 2's, 8's, and 9's. And we've got 6 of those spots to do it in. Now, neither of these can be 2, though, because there's already a 2 in the box. So those have to be our other 8, 9 pair. And we know how to disambiguate it because of these given 8's and 9's because of the disjoint groups. This has to be an 8, that has to be a 9. Wait, I did something wrong. Ah, I see what I did wrong. So, I said that 6 and 7 were accounted for in the disjoint groups, and they're actually not. We've only accounted for 1, 6, and 1, 7. We still need to get more. We still need to get one more 6 and one more 7. So we've accounted for all the 3s and 4s. We've accounted for all the 1s and 5s. What we still need to account for is, in these squares, they can't be 1, 3, 4, or 5, so they have to be 2, 6, 7, 8, or 9. These guys can't be 2 again. So these could be 2, 6, 7, 8, or 9. That one can't be a 9 because it's on a between line. That can't be a 9 because of the disjoint groups. That can't be a 9. That can't be an 8. That can't be an 8. This can't be an 8. So just cleaning up a little bit there. Now, that does tell us that the 25 does have to contain both 2's, because this is literally the only place we could put 2's in those two disjoint groups at this point. So once it contains both 2's, what we have left is 21. And there, I think, are still a number of possible ways to make 21 at this point. Oh, because this is a 4-8 pair, that means there's a 4 pointing at this square no matter what, so that can't be a 4. That's either a 5 or a 7. That's kind of interesting. That could make a parity argument. So we've used an odd number plus 2 2's, so we're at an odd total. And that means that the last two values in there have to sum to an even number, so they have to have the same parity. Again, could be like 7 and 9, could be like 6 and 8, hard to tell. Okay. Again, it's a start. It's a start. We are getting somewhere. It just shows that just persevere and it'll pay off in the long run. I hope that's what we're demonstrating anyways. Yeah, this puzzle's great. I really do like this. It's just very, very, very challenging. Disjoint groups are really not easy. So maybe this 12, we know it doesn't have a 1 or a 5 in it. So how can we make a 12 without a 1 or a 5? It could be 2, 3, 7. It could be 2, 4, 6. And I think that's it, because the only other options are going to be 3, 4, 5, and then the ones that have 1 in them. Now, some of these are going to be impossible, because, for instance, so here's an easier way of looking at this. So it can't be 3, 4, 5 to make the 12, and it can't have a 1 anywhere in it. So the only option is that it has a 2 somewhere along that 12 little killer. Well, where can that 2 be? It can't be here or here because those squares both see a 2. Therefore, that has to be a 2. And then this is a 6. And that means this pair is either 3, 7 or 4, 6. And there's not really any way to know which of those immediately as far as I can tell, but I'm sure that we'll get there. Oh, the last thing we have left in a bottom corner is this 5, 7 pair, so this has to be either 5 or 7. And that means, because this actually sees a 5, that means that this one is not a 5, it's a 7, which both cleans that up and tells us that this has to be a 5. And if that's a 7, this can't be a 4, 7 pair, which means it's a 3 and an 8, which resolves this 6 and 9. That can't be a 6, therefore that can't be a 4. Okay, that tells us that the last, just clean that up too, that can't be a 7. The last things we have left in this box are 1, 4, and 5. Neither of these can be a 5, meaning this has to be our 5. Oh, that's great. And one of these is 1, and then there's a 1 like there also. Fantastic. And I imagine there's probably some Sudoku I'm missing at this point. We've used an 8 in the bottom left corner with this 4-8 pair, so this can't be a 1-8 pair, it has to be a 1-9 pair. And that, I think, gives us everything we can figure out about the bottom left corners right now. So what do we have to use next? I mean, I imagine the answer is probably we have to use this 25 clue. We know it has a 5, we know it has 2 2's, so 5 plus 2 plus 2 is 9. That leaves us with 16 left over, and there are two ways to make 16 in a little killer, either 8 and 8 or 7 and 9. The 8-8 thing is unfortunate. Oh, but we can't use 2 8's, because if we used 2 8's to finish off the 25 clue, they would have to be here and here, and that breaks the disjoint sets rule. So it's got to be 7 and 9, which means we have no 8s at all on this diagonal. We have two 2s, a 7, and a 9. Fantastic. So one of those is a 9, one of them's a 7, etc. Now where's the 9? Well, we've already placed a 9 there. So the 9 cannot be... Ooh, I messed up somewhere. Y'all. Ooh, because I just realized I can't place a 9 on this diagonal. Because there's a 9 here, which limits those, and then there's a 9 here, which limits those, because of disjoint groups. Whoops. Okay, let's try again. So, the 25, we know it has a 5 on it, I think. The remainder is 20. It's also got two 2s on it, so the remainder there is 16. I mean, is it possible that that's not a 6-9 pair, that that's actually something else? Where did I screw up? Okay, so this is a 4-8 pair, meaning we have an 8 accounted for in the bottom left corner somewhere, so this is definitely not an 8. So that's 1, 7, or 9. Where did I mess that up? I'm really not sure. Hmm. Well, 5 sees both of those, so 5 has to go here. That means that's a 1 and that's a 5. So this is a slightly different direction we can go in. 1 and 5. So that's all good. What did I do? Okay, let's not worry about that yet. So this can't be a 5. These can't be 5s. There's nowhere else we can have a 5 in a bottom corner, so that does have to be a 5. And if that has a 5 and a pair of 2s in it, because it has to have the 2 from one of these positions and the 2 from one of these positions. So 5 plus a pair of 2s is 9. That does give us 16. Can't be 8 and 8, it has to be 7 and 9. So it's 2, 2, 7, and 9 there. So that means there's no 6 in it. It means there's no 8 in it. That means one of these has to be a 9. Which means 9 cannot be here. So where is the 9? Oh. What do we have in bottom left corners now? We have used 4, 5, 6, 8, 2, and 3. 2, 3, 4, 5, 6, 8. So we still need 1, 7, and 9. So this is 1, 7, or 9. It can't be a 1 because there's a 1 pointing at it. So that's 7 or 9. So where does the 1 go? Okay, so the 1's in one of those. So my guess is that that's supposed to be 9, and we screwed up just a little bit somewhere along the line there. So let's see if we can figure it out. I don't remember why I eliminated 9 as an option from there, so let's just roll with it. Just let it go. Okay. Okay, so I just noticed that I have a 6-7 pair here, which means that we've definitely accounted for our 7 in this spot in the disjoint sets, which means neither of these can be 7. That means one of those has to be 7, which means we've accounted for 7 in this position, which means neither of these can be 7. So that's got to be a 6, and this has to be an 8. Meaning those can't be 8, meaning that can't be a 3-8 pair, which makes this a 9, and makes that a 6. This is a 7. Everything seems to be working out okay this time. So that's a 9. This is a 1-7 pair. So if you're watching the video, you saw me make whatever mistake that was. I apologize. I did not notice, and I'm really not sure what I did. I'll have to go back and check. Oops. Okay. So where does this take us? So the 12 can be either 2, 3, and 7, or it could be 2, 4, and 6. And some of those aren't possible. So for instance, this can't be a 6, so that can't be a 4. But I don't think that's like enough yet. I guess this between line's probably just in here to disambiguate things at the very end. Here we need a 3, 4, 6, 7, 9. 6, 7, 9. These can't be a 6, so this is forced to be a 6 by Sudoku. I'm just seeing if I can place some digits using Sudoku at this point. That's a 3, 4, 7 triple, meaning that this is a 8, 9 pair. Have we already used an 8 or a 9 in either of those positions? I don't believe we have. Now you must really be screaming at me, I'm sure. I'm sorry. So one of these has to be 5. I guess we just go kind of number by number because like I can't scan to save my life under these rules. The disjoint sets rules just makes it very, very hard to see what you might be missing. And I know I've used everything, so at this point it's just disjoint set Sudoku that has to be done. So it's probably driving y'all insane. So this is 1, 2, 4, 5, 8, or 9. That can't be a 1 or a 9. That can't be a 2. These can't be 5. That can't be a 5. That can't be a 2. That wasn't useful. Yikes. Which positions do I need to be looking at now? This is 1, 6, 7, 8, or 9. These can't be 8. That can't be a 9. Disjoint sets are hard, y'all. These are 1, 7, 8, or 9. That can't be a 9. Meaning 9 has to be in one of these two positions. Useless. What am I not seeing here? Like, this feels like it really shouldn't still be this hard. So weird. Like how I still just don't see what to do. Maybe I'm just tired. Maybe it's me. And the only thing I can think of is, like, I haven't used this between line. So, like, what could the ends be, though? This end can't be a 1. This end could be a 1. Or, I mean, it could easily be something else. It's not forced to be a 1. It's got to contain either a 2 or a 7. If we knew which it was, that would be helpful. Well, I mean, let's just go, like, digit by digit. I'm going to start with 6s because it looks like I've got lots of 6s placed. So 6s. Cannot go there. Cannot go anywhere in this box. Cannot go anywhere in this box. Can't go there, there, there. This is embarrassing, but I'm not sure what else to do. Can't go in any of these positions. We're left with only 2 positions for 6s there. Can't go there, there. Can't go here, here, here. So that means that, no, it's not even locked into there. So 6s aren't going to help us. 5s maybe? 5s have to be in those top corners in that cell. Here, here. There. Can't be in here, can't be in there. Wow. Literally think I would be able to place another 5 at this point. Like, really? It's there, there, here, here, and here, here. Even with the disjoint sets, I still can't place another one. Okay. I mean, is it possible for 5 to be on this end of the between line, or is that actually impossible? I don't see why it would be impossible, because, for instance, if 5 is here and 5 is the lower end, we could go 5, 6, 7, and 8, and then either 6, 7, or 8, and then a 9 there. Should I be focusing on what could appear in the ends of this between line? So the center can't be 5 or 6, and that's all really. It could be anything else. Can't be a 2. It can't be an 8. I don't know. And then this position can't be a 1 or a 6 or an 8. And that's all. don't know. Ah, that can't be a 2 because it's in the top right corner. So that could still either be the small end or the large end. Let's look at the 2's now. 2's can't be in any of these positions. 2's got to be up there somewhere. Ah, and it can't be there. So 2 is there, which places our 2 there, and a 7, which places a 2 and a 9. So that's not a 9, and that's not a 7. And this is not a 2. That means our last 2, well, we're going to have a 2 there. Okay. I guess I already knew that couldn't be a 2. That means our between line has to have a 2, which means one end of it has to be a 1, which means that's a 1. It also can't have an 8 on it because the large end is no greater than 7, and the large end cannot be 3. It also cannot be 4. So that's either a 5 or a 7. Now what does that mean? These can't be 1, 2, 7, 8, or 9. It's got to be 3, 4, 5, or 6. This hasn't gotten any more restricted, if I'm not mistaken. That can't be a 9. It also can't be an 8. It's 3 or a 4. And then this is a 3, 4, 5, 6, or 7. Can't be a 5. Can't be a 7. Can't be a 6. So that's going to have a 3, a 4. So if that's a 4, that's a 5. If that's a 3, then this could be either a 4 or 5. Ah, that's a 3, 4 pair in this row. That makes that a 5, which forces a 7 at the end of the between line because we can't have a 5 on the end of a between line containing 5s. That gives us a 4, 7 pair in row 8, which places a 3 here and resolves our 3s and 4s. And in turn resolves these 4s and 8s, which is going to clean up a little bit here with some 8s and 9s. Okay. So then, these can't be 3s. That can't be a 4. These digits have to be 1, 7, 8, 9. So this is either a 1 or a 7. That's not a 7 or a 1. That's not a 1. So this is the only place still I could put a 1 in that row. That means that none of these down at the bottoms are 1s. Useless. Here we still need 3, 4, 5, and 6. That's not a 5, that's not a 3. I think the only place there could be a 2 in a bottom right corner is the one we already placed, right there. Whoops. One of these has to be a 7 in this row, meaning that this cannot be a 7. Okay, I think that's clean. Those are 3, 4, 5, 6, or 8. Those obviously can't be 3s. Those can't be 5s or 6s or 4s. So that's either a 3 or an 8 in the top right corner there. When will this thing crack? Just feels like it's never going to happen. This is 1, 4, 7, and 9 accounted for. So we've accounted for 1, 2, 3, 4, 7, 8, 9. So this has to be a 5, 6 pair, making this a 1, 3 pair. So that's an 8 and that's a 2. Allowing us to clean up a little bit more. We can finally place a 9 in box 5. That finishes up box 5. Awesome. These can't be 7s. So those are 1, 6, 8, and 9 kind of down here. It's not a 4. So now the only place we could have a 5 in this box would be here. Finally, we get to resolve our 1, 7 pair, which cleans up all of box 4. And cleans up most of the bottom part of the grid from the looks. And that's a 1, 9 pair, which resolves to a 9 here and a 1 here. Box 2 is going to resolve. That's a 3, 6, and 4. This is a 3 and 7, which is going to clean up these 1s and 3s down there. 5s and 6s. That's got to be an 8. We already have a 4 in this column, so that's a 9 and a 7 and a 4, and we're finally finished after 2 hours. Thank you for the puzzle just for kicks. I really enjoyed it, even if at times it didn't look like I was. I hope that that you're able to fast forward through this and that it shows you something about the solution path, even though I'm sure I totally butchered it. So thanks again, and I hope that you guys enjoyed. Talk to you later.